Good morning. I am Alexander Gotian of Hi2D, and today I'm going to show you how to solve this problem. A mooncake is in cylindrical form of radius 4 cm and height 3 cm. Some mooncakes of this size are packed into a closed rectangular box measuring 40 cm by 16 cm by 6 cm. Okay, so our first question asks us to calculate the volume of one mooncake. So to be able to picture that clearer, I have already drawn the mooncake for you. As you can see, it's in the shape of a cylinder. So all we have to do is write down the formula of volume per cylinder, which is pi r squared times height. And I already solved it, so the answer is 150.72 cm cubed. This is the volume of one mooncake. So our second question is, at most, how many such mooncakes can be packed into the box? So to be able to answer this question, we would need to find the volume of a box. As you can see, I already drew the box for you to be able to picture it, and its length is 40 cm while its width is 16 cm and its height is 6 cm. What we're gonna do is find its volume. To be able to do this, we need to find the area of the base times the height, which is 3,840 cm cubed. But this isn't our final answer yet, because we still need to find how many mooncakes can fit in this box. So we divide the volume of the box divided by the volume of the mooncake. So that's 3,840 cm cubed divided by 150.72 cm cubed. With this, we can have 25 mooncakes to fit in this box. Our third question would be, when the box is filled with mooncakes, find the volume of the empty space in the box. So here we multiply the volume of one mooncake times 25 in order to find the total amount of volume for all mooncakes in the box, and that is 3,768 cm cubed. Now, what we're gonna do is subtract the volume of all 25 mooncakes from the volume of the box, and that is 72 cm cubed. 72 cm cubed will be the volume of empty space in the box. So that will be our final answer for the third question. Our fourth question is, if the mooncakes are to be wrapped individually, how many wrapping materials are needed? So for this one, we would need to find the surface area of all mooncakes. Since there are 25, we're gonna first find the surface area of one mooncake and multiply it by 25 later on. So surface area of a cylinder would be 2 times area of the base plus perimeter of the base times height. So for a cylinder, that would be 2 pi r squared plus pi d times height. So the surface area, the final answer for the surface area of our mooncake is 175.84 cm squared. We multiply that by 25 to get the total amount of surface area for all mooncakes, and that would be 4,396 cm squared. And that would be our final answer, because we would need 4,396 cm squared of wrapping materials. So our last question is, can a new box measuring 32 cm by 10 cm by 12 cm hold as many mooncakes as the original box? So to draw our second box, I did it in order to make it clear for you guys to be able to picture it. So the length is 32 cm, the width is 10 cm, while the height is 12 cm. So we're gonna get the volume, which is base times height. So that's 3,840 cm cubed. So as you can see, the volume of the second box and the original box are equal. Therefore, we can say that the second box can hold just as many mooncakes as the original box. Thank you.
Good day. I'm Sean Yu, and I'm the partner of Atom Gotian from Hi2D. So today, I'm going to teach you how to solve for the volume and surface area of certain objects. So our problem for today is a solid consists of a cone, a cylinder, and a hemisphere. The base radius is 4 cm. The ratio of the volumes of the cone, cylinder, and the hemisphere is 6:27:4. So first, I drew the figure here, as you see. So this is the cone, which is the ratio 6, and then this is the cylinder, the ratio is 27, and this is the hemisphere, where the ratio is 4. So the easiest to solve for is the hemisphere, since we are already given the radius. So moving here, so this is the hemisphere, and to solve the volume is 4 pi r cubed divided by 6. So 4 cubed times 4 is 256 pi. And divided by 6. So the volume of the hemisphere is 133.97 cm cubed. But that's not, they're not asking for that. We're basically trying to get the ratio 1 so we can easily solve all the problems. So since the ratio of the hemisphere is 4, we divide 133.97 by 4. So it's 33.49 cm cubed per ratio of 1. So then we can now easily get anything. So the first question is find the height of the cone. So as we remember, 33.94 is the ratio 1. So since the cone has a ratio of 6, we multiply 33.94 by 6. And this is equal to, so this is the volume, and this is equal to pi r squared times height divided by 3. So it's going to be 200.94 equals pi 16h over 3. So that we can remove the denominator 3, we just multiply everything by 3. And we would come up with 602.82 equals 16 pi h. So since we're getting the height, we just divide 16 pi from 602.82 and 16 pi h, and we would come up with 12. So the height of the cone is basically 12 cm. So now the next question is find the height of the cylinder. So here I drew the figure of the cylinder. So as we remember, 33.49 is the ratio of 1. And since the ratio of the cylinder from the whole object is 27, we multiply 33.49 times 27. And this equal to pi r squared times height. The radius of the cylinder is 4, like what was given a while ago. So the volume of the solid is 904.23 equals pi 16 times h. So since we're looking for the height, we divide everything by 16 pi, and we will eventually come up with 18 equals height. So the answer to the height of the cylinder is 18 cm. So the next question is find the volume of the solid. So to find the volume of the object, we just simply need to add the volume of everything we found a while ago. So here, we have 904.23, which was the volume of the cylinder. And we have 200.94, which was the volume of the cone. And we have 133.97, which is the volume of the hemisphere, like what was solved a while ago. So when we add all of this, we will come up with the answer 1239.14 cm cubed. This then is the volume of the object. So the next question is find the surface area of the solid. To find the surface area of the cylinder, we first need the equation is 2b plus ph. So it's pi d, which is pi 8, times the perimeter plus the perimeter times height. So the surface area of the cylinder is 452.16 cm squared. Then we get the surface area of the cone, which is pi times 4 times 12.65. Or as we also know, which is pi r squared plus pi rl. So 12.65 is the side length. So the surface area of the cone is 158.88. Then we get the surface area of the hemisphere. The equation is 2 pi r cubed squared. So we eventually come up with 100.48 cm squared. We add all of the surface area of the objects to come up with the surface area of the whole object, which looks like a pencil. So the whole thing is 711.52 cm squared. So here, this is the surface area of the whole object. So that's how we solve this problem.